So the session will be recorded, so we'll be posting this entire session on our website, and also have snippets of it on our LinkedIn page for anybody interested. And after the session is over, I'll also be emailing a link to everybody that registered for the event today. There should be a Q&A pop-up on your screen by the name of Slido, which you can use to ask the panelists any questions. If that isn't showing up for any reason, feel free to just put your questions in the chat window, because I know some people are having issues with that app showing up on their screen. So feel free, either the chat window or the Slido app for the Q&A, and I'll be moderating the questions, and we'll wait till the end of the conversation today to ask our panelists those questions. So the format for today's conversation, we'll have a panel discussion for 40 minutes, and then a Q&A session at the end for about 10 to 15 minutes. So we should be all wrapped up by noon today. So with that, let me just talk a bit more about the webinar. So as I said at the start, the webinar is the first installment of the Elecsoft education series. At Elecsoft, we believe in providing solutions that help drive digital transformation. And as part of that drive, we wanted to foster open dialogue and share best practices with the larger community, which is what gave birth to the Elecsoft education series. Our IT solutions at Elecsoft, they range from software development to robotic process automation. But for this conversation today, we thought we'd focus on a topic where we've had the most experience, which is in software testing and QA consulting. A large part of the solutions that Elecsoft provides fall into the QA and software testing space. And we've noticed that test automation has been one of the buzzwords in this space for the last few years. So we thought, what better topic than test automation to talk about today. And you might have noticed in the invite, we had the words test automation in quotation marks, and that was done on purpose. Our conversation today is going to center around how we feel that the phrase test automation is a bit of a misnomer. I'm going to let our panelists delve into that a bit deeper, but just the gist of it is basically the argument is that evaluating a product by learning about it through experience and experimenting with it, which is what testing is by definition, it's a human process. It requires human creativity and ingenuity, and we believe it's something that cannot be automated. However, it can benefit from powerful tools to help testers do their work. So the idea is that testing can't be automated, but the checking of the output can. And I'm going to let our distinguished panelists, talk more about that over the course of the next hour. So with that, I'm going to get into introductions. We're very fortunate today to have with us Mr. Michael Bolton, not to be confused with a singer. I'm sure he's gotten that over the course of his career. But Michael is a veteran of the software testing industry. He's here with us today. And actually, the idea for this webinar was born after sharing a few coffees with Michael over the course of the summer and the fall. We found a nice spot in High Park in Toronto, and we got to host, talk on a host of topics. And he was kind enough to share some of his insight in the testing space. So we thought we'd share it with the larger community today. Michael has a long and distinguished career in the industry. He is the lead consultant at DevelopSense, where he helps organizations, software development groups, and testers defend the value of projects and products in any development context, be it agile, lean, DevOps, Scrum, or more traditional development models as well. He provides consulting to executives and managers who want the fastest and least expensive testing that still completely fulfills the testing mission. He also teaches rapid software testing. It's one of the world's most highly regarded classes on software testing. And he also teaches a host of other classes, including rapid software testing for managers, rapid software testing for programmers, rapid software testing strategy, critical thinking for testers, and a number of others as well. I'll share the link to Michael's website the Rapid Software Testing website in the chat window, and I'd highly recommend taking a look at some of the services and some of the courses that Michael provides. With that, I'll introduce the second panelist, Raman Lehal. Raman is the founder and CEO of Elecsoft. He has a background in electrical engineering and 15 years of experience in the software development space. He's driven to use the latest technologies and tools to embed efficiencies in delivery as well as organizational operations by automating repetitive and high volume processes. Raman loves building products to make lives easier and safer, which I'm sure he gets from his engineering background. At Elecsoft, Raman has pioneered a culture of transparency and accountability to deliver superior quality software applications for the end user. Raman has grown Elecsoft organically, and he aims to build the company's reputation on a standard of quality and commitment. And part of that endeavor is today's education series, where we want to share this insight with the community and get your input as well. So with that, I will pass it on to the panelists. We'll start with Michael. He has a presentation for us today to dive deeper into the topic. So with that, I'm going to pass it on to Michael, and over to you, sir.
Thanks very much, Uzair. You just have, first of all, given me a very gracious introduction. It reminds me that I'm not in marketing, and you are, which is it's rather gratifying to hear that. So thank you for that. I appreciate it.
You're welcome.
All right, I am now sharing my screen, I do believe, and the topic today is rethinking automation and testing. I prefer to say that it's a way of saying that James Bach originated and sometimes been adopted a lot more through the business lately, that it's not test automation. Testing can't be automated. We'll get to that in more detail in a moment. As you said, I am Michael Bolton. No, I'm not the singer. No, I'm not the guy in Office Space, and I'm no relation to that bozo. So let's move on from there. That's what I do. As I say, Uzair did a wonderful job of explaining that. So let's move on. I teach rapid software testing with my colleague, James Bach. We are fellows with strong opinions, as the t-shirts indicate. Rapid software testing is a mindset and a skill set of how to do testing more quickly, less expensively, with excellent results. And as we travel around the world, there are things that people talk about, and there are things that people don't talk about. Let's see what they don't talk about very much. And why? The reason they don't talk about them so much, I think, is if we're successful in our efforts, that can represent a kind of commercial advantage. More often than not, though, a lot of attempts to implement automation in testing don't go very well, and those failures are sources of embarrassment. So the consequence of that is that the current state of things is not always widely shared. What am I talking about specifically? People don't talk very much about what they actually do in test automation work, and I've got that in quotes. People don't talk very much about what they do in all testing work. They don't talk very much about what machinery really does and what it can and cannot do. And in particular, it seems to me they don't talk very much about how tools could extend testing. After all, tools are, in the same sense that McLuhan talked about media, tools are a medium. Tools extend and enhance and accelerate and intensify and amplify human capabilities in some form. Those capabilities, though, may or may not be good things. Tools can accelerate the speed at which we perform operations, but tools can also accelerate oblivion to things that are happening as stuff goes by very quickly on the screen. So let's see what we are talking about today. What we're talking about, as Uzair alluded to, is testing as evaluating a product by learning about it. We learn about it through experiencing and exploring and experimenting with the product, by interacting with it. And that includes, to some degree, questioning the product, studying it, modeling it, observing it, making inferences about it, navigating through it, map making, thinking critically, analyzing risk, lots and lots of stuff that is not done by checking. Checking can be a part of that process, but checking doesn't do that process. Checking we describe as a mechanistic process for verifying true or false statements, propositions in formal logic speak, about a project's output or about a product state, a product's output or state. So let's not confuse that with testing. Let's not confuse testing with output checking. Output checking is operating a product mechanistically to check specific facts about it, whereupon we get a machine to interact with the product in specific algorithmic ways, to collect algorithmically specific observations, and to apply those algorithmic decision rules to those observations, and then a report, essentially the turning on of a light or the raising of a flag. Any violation of a rule we refer to as a fail. Otherwise, we call it a pass. But testing is so much more than that, because a product can pass a lot of these checks and still have terrible problems in it. Moreover, a product can fail a lot of these checks, and it's not a problem, it's not a big deal. So think in terms of a spelling checker. A spelling checker takes a body of text, tokenizes it, turns it into little tokens, looks for those tokens in a dictionary. If one of those tokens is not in a dictionary, it gets a little red wavy line underneath it. If it is in the dictionary, no little red wavy line. But nobody calls that automated editing. And that's why it's important to do that. Editing is a process whereby a human evaluates the work of another human and points out possible sources of misunderstanding or problems that a machine is in no position to do, because a machine doesn't have social competence and a machine doesn't have awareness. Of course, tools can assist editing, but they can't do editing. So a check, because it is a mechanistic process, can be performed by a machine that can't think like a human, and doesn't have the social competence of a human, but is very quick and precise at logical things. Or a check can be performed by a sufficiently disengaged human being, a human who has been told not to think, who's trying not to think like a human, who's going through a process step by step, and who's a little bit slower and a little bit more variable when it comes to logic. So don't confuse testing and output checking. Output checking is a part of testing. Through the magic of PowerPoint morphing. There we go. Testing it includes operating a product mechanistically to check specific facts about it. But that is embedded in that deeper process of evaluating a product by learning about it through experiencing, exploring, and experimenting. And testing is actually even more than that. Testing is creating the conditions necessary to do that, so that we can help our clients to make informed decisions about risks, problems in the product, and risks. And I would argue that the job of a tester is not simply to verify that a product can work. It's to investigate whether a product does work, whether it will work, when we vary those conditions that are exercised during some checks, when we challenge the product, when we stress the product out, when we imagine what a product is going to perform like, when it is attempting to facilitate or foster a communication between people. Software products get in between people. They mediate interactions that people have. So a big part of doing that is acquiring the skill and the desire, the intention, and the reputation for creating the conditions necessary for evaluating a product by learning about it through experiencing and exploring and experimenting, which includes operating a product mechanistically to check specific facts about it. Now, it's not to say that we don't like checks. It's not to say that we don't like checks. We need a healthy perspective on checking. We like checks. We use checks. Checks can help us identify cases wherein the product can work. Or in terms of regression checking, if the product has suddenly stopped working in ways that are covered by the checks. But let's remember a few things. Number one, testing requires learning. Checks can't learn and they don't learn. People learn and they can choose to learn things from the checks. They sometimes don't do that for reasons which I'll explain a little bit later. Demonstrating the product can work is a long way away from showing that it will work. You can execute or you can automate the execution of a check, the operation of a check, the steps in a check. But there's something around a check which we can't forget about, and that is the skill of designing and programming checks. In fact, I'm trying to create a craze these days wherein we replace the word automation with programming. Isn't that what automation really is? Isn't it programming? Getting a program to do stuff instead of getting a machine to do stuff? What happens when a check fails? When a check reports a failure? Well, the machinery doesn't investigate the check. So notice that 3.1, the investigation that's required once a check has indicated a failure, the machine doesn't do that. While we're at it, the machine doesn't ask itself, is this a good check? Is this still a relevant check? Is this a worthy check? Do we care about this check? Does this check matter? Machinery doesn't ask that. So it's silly, I think, for someone to say, well, let's just automate everything. Let's automate all the testing. And it's especially silly to do that because automating the GUI can be a hideously, a fiddly and expensive thing to do. It rarely represents a reduction in headcount, and it rarely represents a savings of time when you look at the whole picture. Sure, running an automated check happens lickety-split, but the development and maintenance and repair and review work that's involved with those automated checks, that takes a lot more time than people notice. So automating the GUI can be a really, really expensive thing to do because the GUI is designed for humans. It's not designed for machines. There are good ideas, I think, for getting around that issue. So let's be clear, too, on what we're talking about with respect to automation. My wonderful Chambers Dictionary on my iPhone says that automation is a high degree of mechanism in manufacture, the handling of material. Automation is maybe not that appropriate an idea when we think in terms of software development. Certain kinds of operations in software, maybe we could automate those, certain kinds of tasks. But the idea of thinking about software development or software testing, neither one of those things are factory processes. None of them are factory processes. They're design processes. They happen in a studio, not on an assembly line. What about tools? Well, a working instrument, especially when used by hand. Tool is sometimes, according to Chambers Dictionary, cutting part of a machine tool. Could be anything necessary to pursuing, someone who is used as a mere instrument. I'm using him as a tool, you know. Anything necessary to the pursuit of a particular activity. An idiot, that guy's a tool. Or a despicable person. Or this is something that we can latch on to in software, a utility or a feature or a function available as part of, for example, a word processing package or database or some other form of instrumentation. In rapid software testing, what we say as a tool is any contrivance used to fulfill a human purpose. That's what a tool is to us. Anything that extends or enhances or accelerates or intensifies something that people do. A test tool is any tool that we use in the service of testing. Automation for us is any process performed entirely by a tool or a tool capable of that kind of performance. And then just a little throw in here. If we're going to talk about testing, or we're going to talk about exploratory testing, a lot of the time people say, oh, automation allows testers to more time for exploratory testing. What do we mean by exploratory testing? We mean testing. Testing is fundamentally an exploratory process. Now, what happened? Through my career, I started I had the first time I had a job called tester was in 1994. I'd been a tester before that because I'd been a programmer before that. So what happened? Here is, I'm going to give you a little sort of visual description of this. Here's what happened. This is the world of testing. As represented in many people's minds, as represented even in the mind of a tester. There's lots of cloudy stuff in it. There's lots of mystery in it. Managers, a lot of managers like discrete tasks and outcomes. They prefer to think in terms of the world that way. And a lot of this stuff, mind stuff, or even stuff that is visible and observable, is like a mysterious cloud or a set of mysterious clouds to them. But there is a dimension of testing that is, in fact, reasonably legible, visible, observable, and that is the process of checking. Somewhere along the way, checking started to get an immense amount of attention. In fact, during the 1990s, especially, there was an idea that, here's what we do to make testing happen. We give its tester a set of instructions to follow, set of step-by-step instructions, and then we ask the tester to perform those instructions and make specific observations. And at the end of that chain of events, the tester reports a pass or fail. That makes testing understandable or legible to people who don't understand testing very well. The downside of that, of course, is that testing became surrounded by bureaucracy and paperwork. That form of testing, which we might talk about as scripted testing, something where something or somebody else is in control of the testing process, that's what became the focus of testing because you can see it. So testing became overwhelmed by more and more paperwork, more and more of the trappings of it. And then somebody had a bright idea. Since operating a product step by step and then checking its output could be, at least in theory, programmable, a cool thing to do would be to replace it with a machine. And this idea of automated checking grew and grew and grew. See, the great thing is machines don't sleep, they don't get tired, they don't get bored, they don't complain. And the idea of automated checking grew and grew. And notice that all the other things in that mysterious cloud of testing stuff disappeared. And because these are the visible trappings, because they're dazzling, people started thinking of this not just as automated checking, but as automated testing. In fact, back in the day, they didn't have the vocabulary for that. I take at least some credit for reviving the term automated checking in 2009, even though Alan Turing had been saying something almost exactly the same way back in the 1950s. So this is what testing became known as. Now, this follows a rule, which I've just realized that I can now describe as the second law of bad management. I'm tipping my hat there to Jerry Weinberg, who said the first law of bad management is if something isn't working, do more of it. And I suddenly realized that the second law of bad management is if something isn't working, try automating it. This process of following a script step by step and then seeing if the output matched to some specific predicted desired output wasn't working very well. And it was taking a lot of time and it was slow. And so managers decided, well, let's just automate that. And then, since that became known as automated testing, because that's all testing is, right? Just operating the product that way. What's the opposite of that? What's the opposite of automated? Manual. And managers began fixating on the idea that there's a distinction between automated and manual testing. And here's how the distinction works. Automated testing or manual testing is automated testing without the machine. So what do you got? Nothing. You got a human sitting there who is slow and error prone with respect to what a machine can do. That's because a human naturally varies his or her work simply because we are by nature not just error prone, but prone to investigation, prone to deviation, prone to ask ourselves, I wonder why that's so. And as a consequence of that, we end up, that variation in our behavior is essential to the process of stumbling over bugs. We end up stumbling over bugs because we vary what we do. But of course, nobody really wants to hear about problems in the product. And again, in concert with the second law of bad management, if something isn't working, do more of it. So we take that automated, that scripted testing, and we add more and more robots to it until the human is spending all of his or her time caring for the automated checks and not for the other stuff. So here is our audacious proposal to make things right. Put automated checking back in its place. Automated checking is an important part of a development work, but we would argue that it's work best done, most quickly done, most rapidly done by the developers as they are working at the surface of the development work, as they're working on the code where there are code-friendly interfaces available. This is not to say that testers don't use tools during testing. We can have attended checking, where the tester is observing directly the process that the machine is fulfilling and keeping an eye on the checking and helping it if it gets out of trouble. So let's replace that idea of completely automated checking with the kinds of checks where the human is engaged, where the human is watching and observing and helping out the tool if the tool gets in trouble. But there's also all kinds of other things that we can do with tools in order to allow us to do a better job. We can use tools to help us put the data together. We can use tools to help us analyze and pour through log files. We can use tools to help us visualize the output from a product, taking it from and I'll give you an example of this a little bit later on, taking a log file and putting it into a form where we can use our human pattern recognition in order to make sense of things in a way that a straightforward list of output doesn't afford. And we can use tools for our build pipelines. Now, we got to be careful with the idea of a pipeline, because a lot of people see it as a release pipeline, or a build and release pipeline. You got to be careful with that, because a pipeline and a sewer are really hard to tell apart until you examine what's coming out of them. I'll just leave you at that little metaphor for fun. We can use tools to help us create tools. We can use tools to help us investigate bugs. Now, notice that the tools aren't actually doing the work. The tools are partnered with us as human beings as we use our intelligence, our social competence, our capacity to imagine problems, our capacity to identify risks. We can use tools to help us model our coverage. And we can use tools to aid us in experiential testing by recording and observing what testers do and then reviewing it later on. Like the flight data recorders or the cockpit voice recorders on airplanes. We can use that to help review our work and to learn about our testing as we engage with it. And we can use tools to help us report on the status. The tool that springs to mind at this point is Splunk, taking statistical data from what's coming out and allowing us to see that. All of these different ways of using tools are available to us, and what I worry about is that this idea of automation in testing has completely subsumed all these other different ways of helping us use tools in order to get testing work done. Once you've done all that work to write checks, why not use that work in order to generalize the checks and extend them? Why not use tools to generate lots of data? Why not use tools to pull out data and to extremify the data to stress the limits of the inputs, or to randomize inputs? We can do that easily with checks. I don't see a lot of people doing that. We can vary the sequence of our checks. Usually when a suite of checks is run, it's run in order. But sometimes disturbing or perturbing the order of those checks can help us to shake out some bugs. Another thing that we can do is we can use checks to look through log files for error message and to see what's not being covered. And I'd like to show you a little example of that. A few years ago, James and I were involved in a rapid software testing class working with a company local here in Toronto that was writing a product called Metomatic, reviving a product called Metomatic. It's a tool that allows you to coordinate meetings between a bunch of people who are all over the world in different time zones and such. So the idea is that the person starting the meeting sends out a request to people and they fill in when they're available and not. That generated some log files. Here's a bunch of log files, and as you can see, there's a whole bunch of them, and these are sorted, and we could find out where the log file data was, and so on and so forth. We could also filter the log file in order to identify the begin points and end points of a conversation between various bits of the system. Here is the data identifying how many transactions went from one endpoint to another. You'll notice that all that zero stuff. This comes from a set of tests, a suite of tests performed by a bot that James wrote in order to stress out the product. And then here's some other stuff that identifies the endpoints when a bunch of testers swarmed over this. Well, let's use tools to help us with this. When we put this through a product called YED, we wrote a little bit of software, a tiny bit of software, easy programs to write. We prepped some data from the logs, and then we used this free diagramming tool to use it. The boxes are destinations or endpoints on the site, and the gray lines here indicate when there was a transition that was done from one endpoint to the next point. What we found out about our coverage when we did this was something really amazing. There was a whole screen, a whole set of screens that we hadn't known about. The developers didn't even identify these as things that were available to us. Testers stumbled over them because the testers were interacting with the product and trying to make sense of it. Here's the data from the bot. This is from a tool that James created to stress out the product. Now, what was wonderful about this particular example was that when James punched all these transactions through, the automation created a bot to create a meeting, and then 255 different bots responded to the meeting request. Each bot had a diminishing number of time slots available. What we found out from this was a terrible crash in the product that happened when you stressed it out sufficiently. That's what we could use tools for really well in this circumstance, to add stress to the product. But what the product didn't do is wander around and create those complex flows that humans will naturally do. You can do that with software. It's much harder to program it with software such that the software is making sense of it. This is what happens when people test. This is our rendering of that same data that I showed you in list form earlier on. Now, our point here is not that automation is bad, but that automation can help us make stuff that allows us to see this and contrast it with that. Automation can help us make sense of our testing. Tools can give us checking superpowers, but other kinds of tools can give us observational and analytical superpowers. Yet we don't talk about those kinds of tools very often. So there may be lots of data available. You can use existing checks for cheap performance testing. You can go dumpster diving. You can look for empty or uninformative responses or missing error codes or that sort of things if you're interacting with the API as a programmer would. Another suggestion that I would make for people who are managing testing or people who are performing testing is just try to track how much time you're spending on preparing and maintaining and interpreting checks, and then compare and contrast with the time that you're spending on other forms of testing, other forms of interaction with the product, and then contrast those two things with the bugs and the problems that you're finding and tell stories about those. Use tools by all means, but let's look at how beneficial certain kinds of tools are with respect to other kinds of tools married to human interaction. There are also kinds of checks that we can use that aren't GUI automation checks. We can check for the presence or absence of files, versioning problems. Those are really easy to write, and they're great for people who are just starting to learn how to use programming and testing. Check for corruption in the database. You might want to do that directly. If you do that through a long GUI-oriented transaction, debugging can be really hard. So if you are doing automated checking at the GUI, use also tools that monitor the state of the database and create it so that you're doing that, monitoring the state of the database directly and not just through the GUI, because there are going to be subtle problems that occur that you won't necessarily notice because they won't present themselves through the GUI. You can use tools to check for missing configuration or bad configuration things, or to perturb the configuration. So, almost done here. If you want to find low-level problems quickly, get the programmers to create unit-level or low-level checks, fast feedback, and by their nature, the interfaces for that are mechanistic. I just mentioned the idea of monitoring the database directly. Do you need to do regression checking of an API? That's kind of cool. Do that. Use contract tests for that. That's what they call them. I would call them contract checks, but that's okay. The nice thing about those is because it's a sort of set of agreements between the consumer and the producer of an API that these transactions with this input will return these results. But don't stop there. If you have testers who are programming savvy, Get them to try to do things with the API, to build things with the API. One of the things I've noticed in doing API testing is that APIs are terribly documented most of the time. They're not that useful to the people who haven't created them if the people who are going to use them are going to use them effectively. So get a tester who is skilled in programming to use that API and to report on anything that he or she finds confusing or frustrating or annoying or irritating. So those are just some examples of how we might do better kinds of testing and checking work. Let's just remember, green checks are not the goal. Green checks aren't the goal. The goal is learning about the product. If we see inconsistency in the product, a lot of people dismiss that as flaky tests or flaky checks, but there are no flaky checks. It seems to me they're flaky interpretations of what the checks are trying to tell us. But if there's an inconsistency, investigate it. And if you can explain the inconsistency, you might want to ask why you're performing the check at all. Another example of this, if you need wait states to make the checks work, you might be seeing a performance problem. So might be a good idea to pay attention to that and to put that kind of logging into your checking protocol. If you're finding it hard to get at elements using a GUI check, well, then you've probably got a testability problem. So that is where I'm at with respect to using tools and using checks in software. And now I guess it's time for Raman to provide some rebuttal or some other dimensions of the work.
Yeah, no, thank you so much for that, Michael. It was a very robust and detailed analysis of the topic. But I'll pass it on to Raman to give some of his insight and experiences that he's encountered during his time with Elecsoft. Over to you, Raman.
Yeah, thanks, Michael. So, and I'm actually fully aligned with you, Michael. I think we've gone way too far into checking and then finding all of the tools just for checking and sort of forgotten about the testing part. The way I look at it is the difference between checking and testing is instead of a product, let's think of a human as a product as well. Checking is, does the person exist? Is the person there or not? Testing is understanding the person, getting to know them, getting to understand their personality. That's learning about the person. That's what testing is. So that if you behave a certain way towards a human, we should know what their response is going to be or what their reaction is going to be. That's what the testing is. Understanding, learning about your product or software or the human, any way you want to look at it. So I'm fully aligned with you on that perspective. And then when we think about how do we plan to test or how do we plan to check, how do we ensure we're not putting all of our efforts or planning or strategies towards checking, and how are we keeping testing our focus? So one thing is to always remember that when you're interacting with your product, are you learning something from it? Step away from the binary. Did the check pass or did the check fail? Is the answer yes or is the answer no? It's not that. It's we're giving what's our interaction with the software, with the product giving us back. It's not about as also Michael mentioned, checking is again part of testing. We do have expectations of our product, of our software. We do want to make sure our expectations are met, but you can't do that without interacting with it, without learning about it. How do you know your expectations are met? Unless you interact with your product, unless you try to learn from it. So that's how we always keep in mind when you're devising your test plans and test strategies. What are you doing to learn from the software itself or your product? I keep saying software because that's sort of what we've been working with, but it's any product. If you buy a new cell phone and you get it delivered to you, you don't say, let me check it. You say, let me test it out. Let me test out how it works. Let me test out the product, any new product that you get delivered to yourself as well. So keep the focus on testing. And I know in our companies and organizations, we're always talking about testing, but it's very it's sort of always tied to checking. But in our mind, we have to now sort of shift from the testing to learning. Let's learn the product. I think we have to sort of start saying that and start thinking that way instead of just saying let's test the product, let's test the software. Let's learn what it does. Let's learn what it doesn't do. Let's learn how it will fail. Let's learn how it will never fail. Right. So those are some of the things we have to keep in mind when we're testing. Or when we're devising our plans for testing. And of course, sometimes you do have to do the checking. For example, you're launching your product, it's deployed, and now it's in production environment. You need to do sanity checks. At that point, you're just checking, is the code there or not? That's all you're doing. At that point, it's too late to learn. You should have learned the software ahead of time in earlier your phases of your testing. At that point, you're just checking, we've deployed the code is there. Maybe you do a quick couple of happy tests to make sure your expected results are still the same. So sometimes you do have to check, and in certain phases, for example, I mentioned 70, you can only do the checks, but anything prior to that, it has to be testing. It has to be learning what the product is doing. And the other part is, how do we select the tools? When we think of tools, the main purpose of tools is to make your life easier and make your work more efficient. That's all it is. So you have to look at, in your organizations, where are the inefficiencies? Where are people spending a lot of time with not a lot of learning of the product, but just doing the checking of the product? So we have to look at, identify what are those inefficiencies, and then think about what are some tools are there any tools that are available out there that can help us with those inefficiencies and add greater efficiency to our organization? And then we start looking at, okay, do we need that tool? Maybe all the team is just working on the checking part of things. Maybe we want to automate that part, but that feedback from the checking has to go into the testing team members. It has to go to the team, say, okay, we've got the checks back. What does it actually mean? What does it actually teach us about the product itself? So I think that's what we have to really, when selecting the tools, that's what we have to really look at. What are we actually, where are the inefficiencies? How do we reduce those efficiencies? Maybe by using tools. Maybe you don't need to do those checks at all. Maybe there's a better way to do those checks. So identifying those tools, and then making sure the output of those tools is then used to learn the software, to learn the product. So that's how you would want to make sure that you're, again, when selecting the tools, the purpose is to learn again, and then whatever tool you want to use, it's mostly to increase the efficiency in your organization, or in your testing phase, or whatever you might want to call it. I think that's pretty much it from my side in terms of how do you ensure you're planning for testing and not always for checking, and how do you select your tools? Of course, there's other criteria for selecting your tools as well. Is it ease of use? Is it can the organization use it across all domains, all departments within the organization? Does it provide real-time data, real-time dashboards, real-time reports for you to be able to then translate that into what you're after? I think I already mentioned flexibility of use. Does it integrate with your other tools that are using within the organization? So you have to keep some of those things in mind as well. But the main thing is your tool helping you reduce the inefficiencies in your organization or on your team? So that's my couple of cents, Michael and Jose there.
Yeah, thanks, Raman. And so we'll open it up to questions. And I think one that I received privately, a question was more specifics around the tools that are available. Like, do we have a list of those tools, or can we Do you have suggestions on specific tools that are helping on the checking part of it, which can then integrate into your testing plans? Are there any specific that you've come across that you feel are doing the type of automated checking and integrating it with the testing plan in a way that that makes sense?
As a member of the context-driven school of software testing, school of thought, it's not like an institution or anything like that you attend, I have to say there's no good answer to that question outside of specific context. That's kind of discouraging maybe for the person who's asking, but in order for me to give a responsible answer to that, I'd have to know something more about you and the problem that you're trying to solve. This is actually kind of a pandemic disease in the testing business. This idea that there's a tool. It's like asking, well, what's your favorite house building tool? Well, it might be an architectural table. It might be a hammer. It might be a sawzall. It's really important for me to understand the problem. But I'm happy to offer that to anybody who would like to engage. And I'm not hard to find on the web. And I bet Raman and Elecsoft will be happy to do that too.
Yeah, definitely. It's again, as Michael mentioned, as I was also mentioning, before you think of what tool you require, you have to know what do you need to do, what do you need the tool to do. So in house building example, you need to put in nails through the drywall. You're not going to, you're going to use either a hammer or a nail gun. You're going to use a level for that. So it really depends on what is the problem that you're trying to solve, and then based on that you would select your tool accordingly. And since this topic is more about automation, the way I look at automation is, or automation tools is, if it's automation, it really has to do everything. It really has to, capture everything, capture all the screens, capture, every screenshot, capture every input, output, any errors, and to a point has to translate it to me, for me to a certain level, and say, hey, you have this many errors in this part of your software, which means your e-commerce website, the checkout process will not work. So it has to, if it's automation, it has to really come down to that point. Otherwise, it's really just checking. So we have to look at, again, since we're talking about automation, there's a tool called Koala that I've come across a few times, and I've been working with those guys as well. That tool, all you really do is, it's very easy to configure. You enter your web application URL, you let it run. It takes some time to learn. It's AI based. It's a reward based machine learning algorithm. So what it does is it's rips through your application, takes all screenshots, captures all the videos, logs any errors that it comes across, and then you have the opportunity to go analyze it, look at the videos, and see where the failures were, what was the input when the failure happened. So when I'm thinking of tools, it would really have to ensure it's solving the problem that you're specifically trying to solve, or add the efficiencies that you're trying to add. Because remember, tools are to help us. The tools are there to make our life easier. So we have to see where is our life hard, and then sort of decide and then look at what tools are available to solve that particular problem.
Beware of AI too. I have to say, AI is like we've got this dog. We got a dog in the beginning of COVID for my daughter. We got a dog, and she's a very bright dog, as dogs go. She can be trained really well, but somewhere along the way, she got the idea that when somebody came to the door, it'd be really important to offer a gift, a shoe. So she would grab a shoe, and of course we rewarded her for that, right? We thought it was really cute, and so we said, we laughed and we said, "Oh, good girl," and she wags her tail and all that sort of stuff. Well, there's a couple of problems. Now we've got shoes distributed all over the house. In fact, right here, I come to my desk this morning, and this is what the dog has brought us. And AI is kind of like that to some degree. It can do interesting things, but you've got to be careful how you're rewarding it. Otherwise, you end up with shoes all over your application. It's good to have a dog, but the dog doesn't exactly know what you want. The dog feeds and responds very much on how you reward it. And the dog doesn't know why you want a shoe. The dog just knows that you smile and laugh and pat it when it brings a shoe. So you got to be careful about that kind of stuff.
So another question I had here, and it's an anonymous sender, but they ask, how do we promote more value of manual testing to management who is only focused on getting automated checking scripts?
My first reply would be, first thing, stop talking about manual testing. And I posted some links in the chat. The first one is alternatives to talking about manual testing. Let's, instead of thinking about manual testing, let's think about experiential testing. Let's think about attended testing. Let's think about exploratory testing. And just the word manual is, because of the phenomenon I described midway through, manual got flipped from just testing. There used to be a thing called testing. And then as soon as automated checking came in, it dominated things. And now manual testing is seen as automated checking, but without the machine. Testing is so much richer than that. In terms of practical things to do, tell stories about how you found bugs and where you found bugs and how the machinery helped you and how the machinery might have slowed you down or got in your way or made things harder. What I would recommend is keeping a journal wherein we learn something from every bug. We describe how we found the bug. We describe what the oracle was, that is the means by which we recognize the bug, and the degree to which tools might have helped us if we had them, or did help us if we did have them, the degree to which they got in our way if they slowed us down from finding bugs. And here's the key. Unfortunately, nobody wants to hear about problems. Nobody likes problems. But testing is all about finding problems in the product before it's too late. And as testers, we're the only people in the project whose focus is on finding problems. And we got to remember that. So tell stories about finding problems and how the finding of those problems helped management to be able to decide, is this a problem worth fixing or not? Well, I guess we'd better fix this problem if we're going to ship. That's how we got to do it. We've got to get a richer idea of what testing involves. That's what I would say.
Yeah, and have those conversations with the management. Management actually might not be even aware of the difference between testing and checking. For them, it might be one and all. It might be all the same. So have those discussions with them. Educate them. Testing is a lot different than checking. Use some of the examples that we've discussed here, and that might start the conversation. Of course, it's not going to be one conversation that will change their mind, but it'll over several conversations. Once you've shown them the difference between testing and then checking, and what testing brings to the table in terms of learning the product, I think that will help with the conversations.
Risk is a really big keyword too. Testing helps us to identify risk, business risk, things that threaten the value of the business, by identifying problems in the product that would lead to threats to the value of the business.
All right, well, thank you so much, guys. We have run over our time limit here, and I think we're all done with the questions, but I wanted to thank Michael and Raman again for joining us today, and for all of our participants. Thanks for taking the time out of your day to listen to us. I've shared a link in the chat where if anybody joined late and didn't hear most of the conversation, there's a link, Elecsoft resources, where we'll be posting a link to the webinar there. And also on our LinkedIn page. And so thanks again for joining us for this inaugural Elecsoft Education Series webinar, and we look forward to seeing you at future events as well.
Thank you, sir. Thank you, Raman.
Thank you, everyone. Thank you, Michael. Thanks all.